Pharmapal.
The effects of Anastatica Hierochuntica aqueous extract on prenatal development in rats. Welcome to our channel. Today we're diving into an intriguing study examining the effects of Anastatica Hierochuntica aqueous extract, or AHAE, on prenatal development in rats. This research highlights the potential impacts of herbal extracts on pregnancy, focusing on maternal health and fetal development. Let's explore the findings and what they mean for future research and health practices. In the world of natural remedies, Anastatica Hierochuntica has garnered attention for its traditional uses. However, scientific evidence on its safety during pregnancy is limited. This study aimed to evaluate the effects of AHAE on pregnant rats, specifically looking at maternal weight gain, food and water consumption, and fetal outcomes. By understanding these effects, we can better assess the safety of herbal remedies during critical developmental periods. Materials and methods. To investigate these effects, researchers used 40 female Sprague-Dürly rats, dividing them into 4 groups. Each group received different doses of AHAE, ranging from a control group with no extract to those receiving 250, 500, and 1,000 milligrams per kilogram body weight. The rats were monitored for changes in weight, food, and water intake throughout their pregnancy. Through the treatment period, a cesarean hysterectomy was performed to examine the fetuses and their development. Here's a quick breakdown of the key methods. 1. Vaginal fluid assessment to determine the phase of the estrus cycle. 2. Administration of AHAE via oral gavage. 3. Statistical analysis using tools like SPSS to interpret the data. Maternal parameters assessment, toxicity signs, and body weight measurement. First up, let's talk about how the researchers assessed maternal health. The animals were closely monitored for any signs of toxicity, such as vomiting, diarrhea, death. Daily body weight (BW) measurements were taken throughout the experimental period, leading up to euthanasia. To calculate the corrected maternal BW gain, they subtracted the BW of the pregnant rat at gestational day 21 (GD21) from its initial weight at GD0, along with the weight of its gravid uterus. Corrected maternal body weight gain was calculated by subtracting the body weight of the pregnant rat at gestational day 21 (GD21) from that at gestational day 0 (GD0), along with the weight of its gravid uterus. The findings indicated significant body weight reduction in the 250 milligrams per kilogram and 1,000 milligrams per kilogram AHAE treated groups compared to the control group, suggesting a potential adverse effect of high doses on maternal weight gain. GD21, the pregnant rats underwent a cesarean hysterectomy. In rats, gestational day 21 (GD21) is quite advanced in their pregnancy. Rats have a gestation period of about 21 to 23 days, so GD21 is very close to the end of their pregnancy term. This stage, the fetuses are well developed and almost ready for birth. Here's how it worked. 1. The rats were anesthetized with a combination of ketamine and xylazine. 2. A midline incision was made to expose the uterus. 3. The uterus was carefully harvested and weighed. For the number of live fetuses was counted, and each was examined for external malformations. Determining fetal gender. Fetal gender was assessed using the anogenital distance, AGD, which is typically longer in males. Further confirmation involved checking for the presence of testicles in male fetuses. Cesarean hysterectomy procedure, anesthesia and surgical process. On GD21, the pregnant dams underwent a cesarean hysterectomy. Here's how it went down. 1. The rats were anesthetized using an intramuscular injection of ketamine and xylazine. 2. A midline abdominal incision was made to expose the gravid uterus. Maternal organ examination. Through the hysterectomy, various maternal organs, including the liver, kidneys, and ovaries, were harvested and weighed. The ovaries were then fixed and stained for further analysis. Pregnancy and fertility indices. The researchers calculated several indices to evaluate reproductive performance. Pregnancy index, percentage of pregnant females out of cohabiting pairs. Resorption index, number of resorptions compared to total implantations. Post-implantation loss, the difference between the number of implantations and live fetuses. Pre-implantation loss, the difference between the number of corpora lutea and implantations. Fetal head examination. The fetal heads were sectioned into 4 different sagittal planes for detailed examination. This was done using a sharp blade, and the sections were immersed in Bouillon's solution for further analysis under a stereo microscope. Estrus cycle and fetal head examination. Estrus cycle assessment. Figure 2 presents the phases of the estrus cycle in SD rats observed under a light microscope. The phases include proestrus, predominance of epithelial cells; estrus, predominance of cornified cells; diestrus, predominance of leukocytes; metastrus, fairly equal ratios of leukocytes, epithelial, and cornified cells. Figure 3 in the paper illustrates this process, showing both a pregnant rat and the exposed uterus in situ. Fetal examination. After harvesting the uterus, the researchers weighed and carefully incised it to determine the number of live fetuses. They examined the offspring for any external malformations and recorded their weights. Key terms: anogenital distance, AGD. This measurement helps determine fetal gender, as it is typically longer in males than in females. Fetal head examination. For the fetal head examination, heads were sectioned into 4 different sagittal planes, as depicted in Figure 4. The sectioned heads were immersed in Bouillon's solution and examined under a stereo microscope. Statistical analysis. The data collected were analyzed using statistical software. The researchers employed various tests, including one-way ANOVA with post-hoc Bonferroni test for normally distributed data such as pregnancy weight gain, organ weight, and food/water consumption; Kruskal-Wallis test for non-parametric, non-homogeneous data, including the number of corpora lutea and implantation sites; chi-square test for analyzing fetal sex ratios. A p-value of less than 0.05 was considered statistically significant. Data analysis methods. The researchers utilized various statistical tests to analyze the data. One-way ANOVA for analyzing pregnancy weight gain and organ weights; Kruskal-Wallis test for non-homogeneous data such as the number of corpora lutea and implantation sites; chi-square test to analyze the sex ratio of fetuses. Results and findings. Toxicity signs. Notably, there were no reports of mortality or behavioral changes among the rats exposed to all doses of AHAE. Identification of quercetin. The identification and quantification of quercetin were performed using LC-MS, with results shown in Figure S1. Concentration was found to be 147.9715 ing/ml extract. Maternal food and water intake. Interestingly, while food intake remained stable across groups, water consumption significantly increased in the group receiving 500 mg per kilogram AHAE, but this effect was temporary. Table 1 and Table 2 summarize maternal food and water intake across different groups. Notably, water consumption significantly increased in the 500 mg per kilogram group from GD6 to GD12 compared to controls. Body weight gain analysis. The study revealed no significant difference in weekly body weight gain among groups. However, a notable reduction in corrected maternal weight gain was observed in the 250 mg per kilogram and 1,000 mg per kilogram groups compared to the control group. Table 3 presents the weekly maternal body weight gain. While no significant differences were observed, the corrected maternal weight gain showed a reduction in the 250 and 1,000 mg per kilogram groups, as indicated in Figure 5. Maternal organ weights and reproductive performance. Organ weights. Table 4 details the maternal organ weights, revealing a significant increase only in the liver of rats treated with the highest dose of AHAE. Reproductive performance. The reproductive performance of the dams was assessed using several indices. Pregnancy index, 100% for all AHAE-treated groups. Resorption index, lower in AHAE-treated groups, especially the 500 mg per kilogram group, compared to the control, suggesting that AHAE may have a beneficial effect on maintaining pregnancies. The study also calculated pre-implantation and post-implantation loss rates using specific formulas. Table 5 showcases the reproductive performance metrics, including a 100% pregnancy index across all groups with varying resorption indices. Fetal parameters and observations, fetal body and placental weight. Table 6 compares fetal body weights and placental weights across groups. Significant reductions were noted in both male and female fetuses from the 1,000 mg per kilogram group. Fetal outcomes, external features of fetuses. Key findings regarding fetal development and malformations. The fetal examination revealed several significant findings. A malformed fetus with unilateral cleft lip and palate was observed in the 1,000 mg per kilogram AHAE group. The anogenital distance index, AGDI, was significantly increased in fetuses from the highest and lowest dose groups, suggesting masculinizing effects. Notably, the 500 mg per kilogram group showed no significant adverse effects, indicating a potential protective effect at this mid-dose. Cleft lip and palate in fetuses from the 1,000 mg per kilogram group. Hydrocephalus was also noted in one fetus from the same group. The study also noted external malformations, including a fetus with unilateral cleft lip from the 1,000 mg per kilogram group, shown in Figure 6, and another with the absence of a tail from the 250 mg per kilogram group, shown in Figure 7. These findings suggest that high doses of AHAE during pregnancy can lead to significant adverse effects on fetal development. Non-monotonic dose response curve. The study highlighted a non-monotonic dose response curve, indicating that lower doses could also have adverse effects, which is contrary to typical expectations where higher doses lead to more toxicity. Discussion. Maternal weight and intake. While food intake remained consistent across groups, water consumption significantly increased in the 500 mg per kilogram group. However, no significant differences were found in overall maternal weight gain. Fetal outcomes. The study found that fetuses from the 1,000 mg per kilogram group exhibited lower body weights and some abnormalities, including a case of unilateral cleft lip. Interestingly, the 500 mg per kilogram group showed the best outcomes, with fewer resorptions and higher survival rates. Effects of herbal extracts on pregnancy. The findings suggest that herbal extracts like AHAE can have both beneficial and adverse effects on pregnancy outcomes, highlighting the importance of dose-dependent responses. The non-monotonic dose-response relationship observed raises concerns about the safety of herbal supplements during pregnancy, necessitating further research to understand the mechanisms involved. The findings suggest that while AHAE may have some beneficial effects at lower doses, higher doses could pose risks to fetal development. The non-monotonous dose-response curve observed indicates that both high and low doses can lead to adverse effects, a phenomenon that challenges traditional views on dosage safety. Thank you for joining us today. Don't forget to like, share, and subscribe for more insights into fascinating research topics.
Pharmapal.